y, but don't forget you will have your 4x going to the other side, so it's going to be negative 4x. The final step is going to be like this. Take y dash as a common, and it's going to equal to. For this part, I will write it once more. Negative sign of x plus y, then negative 4 of x, and all of this is divided by 2 of a y plus the sign of x plus 1. I think this is the main shape of our problem. We start separating, first of all, getting common factors, then collecting the value of y. In a similar manner, if I want to get the nth derivative for y equal 1 over x, which is really very simple, all I have to do is to have a multiple derivatives for this function. And I'm y, which equal to 1 over x. First step, get y dash, or reform this function to be similar to mu, x to the power of negative 1. First derivative is going to be negative 1 times x to the power of negative 2. Don't multiply your numbers, just leave them as it is. So, getting y double dash would equal to negative 1 times negative 2 times x to the power of negative 3. Getting y treble is going to be negative 1 times negative 2 times negative 3 times x to the power of negative 4. Then blah 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 till you reach yn, which is going to be equal to. Start remarking. Negative, positive, negative, positive. The simplest way to deal with this is just to write negative 1 to the power of n, and then try it. Right? As you see sign conversion, right, negative 1 to the power of n. First, then try it. If we inserted 1 instead or substitute n by 1, it's going to be negative. First, n equal 1, it's negative. So, if we replace n by 2, we are talking about the second derivative, it's going to be positive. Yes, it's working, so it's correct. The other step, once we have y dash, we have 1. We have y double dash, we have 1 times 2. We have y triple, 1 times 2 times 3. So once we have nth derivative, we will have factorial n. And once more, let's start. If we get y dash, just substitute n by 1. So if we substitute n by 1, it's going to be factorial 1. But if I inserted 2 instead of n, you are talking about y double dash. So you will have 1 factorial 2, which is 1 times 2. The other one, when you replace n by 3, you will have 1, 2, 3. Here it's going to be factorial 3, so you are in very good shape. Second part, in all of them, we have x. So I'm going to write x, and all of them with negative sign, so negative. And let's see. Y dash, first derivative, the power is 2. Second derivative, the power is 3. Third derivative, the power is 4. For nth derivative, I'm sure it's going to be n plus 1. This is the nth derivative rule. Let's try it. Let's replace every n in this form by 1. We are talking about the first derivative. Once we do this, you will have negative 1 times factorial 1, which is 1. Yes, it's negative. And then x to the power of negative 1 plus 1, it's negative 2. It's correct. If you try to insert the 3, I think it will be working. This is going to be negative. This is going to be factorial 3. This is going to be 3 plus 1, which is 4. It's really correct. Okay, for the third problem, he asked you to find the mixed derivative, the mixed partial derivative. Once you see this symbol, it means that z, y, x, it means we are going to differentiate, but partial, the function which is z for 2 times, and I see 2 symbols. The first of them, it's going to be the one inside, or the starting one from the left. So it's going to be partial y times partial x, which is simply going to be partial for partial x for the function which is partial z, partial y. Start first getting the derivative with respect to y, then start differentiating with respect to x. So all I have to do is to get first the derivative of this function with respect to y. Getting the derivative with respect to y, x squared, x cubed is going to be 0. This part is going to be negative sine times negative. This is partial x, open the bracket. Then start differentiating, it's going to be positive 3a, which is going to be sine for x times y. Stop. You are differentiating with respect to y. Once we differentiate with respect to y, x is a constant. So it's exactly like differentiating 2y. So you will have sine 2y times 2. So I will have x here. Then you will have y to the power of 3, which is going to be simply 3y to the power of 2. Last step, start differentiating with respect to x. This part will be cancelled. And now we have to start differentiating with respect to x. You will have two parts. I will start differentiating the first part, which is going to be 3a times sine of xy, then plus, you will have 3a of x times cosine xy. This is angle. Don't you forget that you will have to multiply by y as you are differentiating with respect to x. So y is, as I said previously, is just a constant, so will appear in front of you. This was mainly the main methods. Also, please try to review how to do a parametric derivative. I will see it in the other lecture with many students. Okay. Still, also remember that we have Maclaurin and Taylor. This problem is really very important. You will be required to find an expansion of Taylor or Maclaurin through your final exam. But if I need to find an application, don't use Maclaurin. Use Maclaurin just only when you try to get a value of 0.3, 0.4, something like this. If you have, because the main idea of making an application using an expansion is to find the nearest value that this function will have a known or famous values for you. So, instead of searching or finding sine 31, I will end up expanding at sine 30. As we already, all of us, know the values of sine 30, how it's going to be from the 30, 60 triangle. So, first of all, I will have to find the expansion at 30. But still remember that Taylor and Maclaurin expansions already contains x values outside the given function. So if you are dealing with trigonometric functions, you will have to deal with radians. I'm dealing with radians if you are multiplying x times certain value of an angles. And x is playing the rule of two parts, x as a variable or as a number times sine of x as an angle. In this way, you will have to go through radian coordinates. Other than that, x is going to be in degrees or grades, and the x values supposed to be in radians, as you know. Okay? First of all, I will make the decision, the right decision or the right value to use. Instead of dealing with 31, I would deal with 30, and then I will try to substitute by 31. So I'm actually getting an expansion about x equal 30. First of all, you will have to write the law. The law you already have it, f of a plus f dash a times x minus a plus f double dash a divided by 2 times x minus e to the power of 2, blah, blah, blah. First of all, I will need to get f of f dash, f double dash, f triple, fn, if you like. First of all, f of x equals sin x, f dash cosine x, f double dash is going to be negative sin x, f triple is going to be negative cosine x, f4 is going to be sine. Then I will start substituting. Here x equals 30. It will make no difference at this time if x is in rod or x in degrees, because you are dealing with trigonometric functions. So sine 30 is going to be half. Cosine 30 is going to be root 3 over 2. Blah, blah, blah. I've got the values. The second step, or the step after this one, I will try to substitute. then I'm going to give the approximation about sine of 31. Remember, I already made the expansion at sine 30. Okay, so you have f at 30, f dash at 30, x minus 30 pi over 100 over 80, and so on. Don't use x values in degrees. For the sine values, it will make no difference. But for writing this value of x, you will have to first determine the value of 31 in radians. This is the value of 31 ingredients. Start substituting. بعد ما تعمل substitution, after substituting, you will get the approximate value. For this problem, if it has 10 marks, I've already considered 8 of them for the right steps, and just only 2 dedicated for the final answer. Okay? Please start to go through these applications. It's already written, or you will find it in the expansion part of Taylor and McMillan. Here is asking you about some and these stresses that you can use L'Hopital. In the exam, I don't remember if I've asked you to use L'Hopital or just to solve them as well. If I want to solve these problems, remember there is just only one condition in dealing with L'Hopital is to have 0 over 0 or infinity by infinity. So all I have to do simply is to start substituting. If I start substituting in this problem, you will have e power 0, which is 1, times 0 minus 0, divided by 0 plus 0, so you will end up having 0 over 0. Once I have 0 over 0, now you will have the right to use L'Hopital theory. Once you start using L'Hopital, you have to be careful about your substitutions. Limit x tends to 0. Start differentiating. I'm going to differentiate the denominator by itself, and then I will differentiate the denominator by itself. Differentiating the denominator, you will end up having e to the power of x times sine x plus e to the power of x times sine x, then minus 1. I've differentiated this part, which is simply e power x times sine x, plus differentiating sine x, which is cosine x times x, differentiating x, which is going to be 1. For the denominator, it's going to be 5 of x to the power of 4 plus 6x. Then I will start once more substituting. If I start substituting once more, you will end up having 0 over 0. Remember that the 0 factor didn't leave the denominator, you still have x. And for the denominator, see, we have e to the power of x, and you will have sine 0, which is 0, so this part is cancelled. For this part, e to the power of 1 times cosine 0, which is 1, so 1 minus 1 is going to be 0 also. Start using L'Hopital once more. So if we try to use L'Hopital once more, the denominator will end. So you will have 6 plus 20 of x cubed. This is the limit, which x tends to 0. Start once more differentiating e to the power of x. It's going to be e power x times sine x. Then differentiating sine, which is going to be cosine x times e power x. Start differentiating this part. The derivative of e power x will remain e power x cosine x, so you will end up having a 2. Differentiating cosine will give you negative e power x times sine of x. Then finally differentiating negative 1, which will be cancelled. If you try to substitute, you will find this part is cancelled with this one. You will have 2 divided by 6, so the limit is 1 over 3. This is how to get your value. These, I've wrote L'Hopital here, also write L'Hopital. This way, you will be in a very good shape. If you make any mistakes, I will find at least, or I will understand at least, you are differentiating, you are using L'Hopital, so there will be minimum grades for you. If I start substituting in the other problem, لو أنت بصيت على البروبلم اللي جنبها, start substituting, you will have 1 divided by 0, minus 1 over 0, which is going to be infinity, minus infinity. It's also undefined, but you can't use logarithm. I can't use logarithm except we have 0 over 0 or infinity by infinity. In order to do this, you will have to have a common denominator. So the first step is to write limit x tends to 1. Start having your common denominator, which is going to be ln x times x minus 1. Those two parts divided by x minus 1 will deliver x times ln x minus, once you start dividing on ln x, you will have x minus 1. You will have something like this. Once more, start substituting. Once we start substitution, you will have this part is going to be 0. This is going to be 1 times net 1, which is 0. So you will end up having 0 on the denominator, and on the denominator, you still have 0 times 0, which is 0. Now you can use logarithm. Here we can use logarithm. Starting from this point, on this form, you can't use logarithm unless you have 0 over 0 or infinity over infinity. Start differentiating using logarithm theory. So simply it's going to be like that. This is going to be limit of an x tends to 1. The first part is going to be x times 1 over x, then plus ln x. The other part is going to be negative 1. And all of this divided by two functions multiplied each other. So you will end up having x minus 1 over x. Then don't you forget that plus ln x, which is something like this. Oh, does it have a nice look? So start to simplify it as much as possible. Before you proceed, start to simplify. Remember, you have x, which is going to be equal to x you deliver positive 1. Positive 1 was negative 1, they will be cancelled. You have just only ln x, which is 0. For the denominator, stop. Don't make substitutions at the time being. But instead, if we take x as a common denominator, you will have ln x tends to 1. I will write it here. See how the denominator is going to be. I will get a common denominator, so it's going to be x minus 1, then plus x times ln x, okay? All of this is divided by x. And for the denominator, you have just only ln x on the denominator. You already know that a denominator of a denominator is a denominator. So instead of having this shape or this complex form, it's simply limit x tends to 1 for x times ln x, which is simply divided by x minus 1 plus x times ln x. Start substituting for this function at the time being. You will end up having 0 over 0. Ln 1 will develop 0. 1 minus 1, which is 0. Ln x, which is 0. Start differentiating once more using logarithm. Then you will have limit x tends to 1. The denominator will develop ln x plus positive 1. The denominator will develop 1, then plus ln of x, then plus 1, which is simply going to be 1 over 2, and you're done. It has a very nice calculation. At least you will have to solve in this part, in logarithm, you have to solve a mean problem. This is not really a must thing to do. For solving a problem on the mean from 0 over 0, 3 to infinity. But start thinking about, if you don't have the mean form, start solve 1 or 2 from these problems. How to manipulate the undefined values in order to reach the condition 0 over 0, infinity by infinity, and then you start differentiating. And also try to solve one of these problems with a power. Like getting the limit, like one of the very, very famous problems on this part, you have to solve 1 or 2 from these types. If I need to solve limit x tends to 0, x to the power of x, for example. And if you remember, we will consider this problem equal to y taken for both sides and start proceeding with the steps. Don't you start differentiating unless you have 0 over 0 or infinity by infinity. That's the condition for doing it. This part also is very, very nice and will be involved in your final exam. Wow. This is the investigation problem. Also, it will be a part from your final exam and it's really, very important. 10 marks will be granted for this problem. As 10 marks was granted for this problem in the previous exam. This is really very simple. I can also add more marks on this problem. You have differentiation, you have the knowledge of asymptotes, you have to know how to draw. Actually, this function, it's really very, this part is really very important part of your application to the end of the derivative, and it was the final problem in your final exam. To the tenth problem. First of all, I will have to find the asymptotes. The asymptotes, the first of them, remember the rules, the first of them is to just look at this problem and try to find or to figure out when x, what is the value of x that will make this problem tends to infinity. I have x squared plus 1 divided by x plus 1, which simply will happen once your denominator equal to 0. So insert x plus 1 equal to 0, and this will develop x equal to -1. At this value, you will have a vertical asymptote. First of all, you will have to get your asymptotes. So I have a vertical asymptote for this problem at x equal -1. This is number one, you have to know. Second step, try to remember how to get an inclined asymptote, which is simply y equal ax plus b. In order to get a horizontal or an inclined asymptote, I will have to write the law for a, which is simply limit x tends to, do you remember? F of x over x. Limit x tends to infinity of f of x over x. All I have to do is to just write this function on this board. So simply I will have limit x tends to positive infinity. It's supposed to do this step twice. One for the positive part of the x-axis and one for the negative part of the x-axis. This is going to happen when you have exponential functions. But if you have a function like this, a polynomial in the denominator or a rational function, or it will make no difference. So I'm just going to keep it with x tends to positive infinity. Start substituting. You will have x squared plus 1 divided by x plus 1 divided on x. So it's going to be in this form. That's limit of an x tends to infinity of x squared plus 1 divided by x squared plus x. You have infinity over infinity. Of course, I will need my saver, which is log. Let's use logarithm, which is going to be simply limit x tends to infinity. You will have 2x divided by 2x, which is going to equal to 1. Once you have a value for a, you have inclined asymptote. You don't have a horizontal asymptote. Okay, I will need to get the value of b. Now I know a, which is 1. In order to get the value of b, just remember the law, which states limit x tends to infinity of f of x minus a times x. Start substituting, limit x tends to infinity of x, which is x squared plus 1 divided by x plus 1 minus a, which is 1 times x, which is going to be x equal to, this is the limit, x tends to infinity, get a common denominator for all of them, which is x plus 1. You will have x squared plus 1 minus x times x plus 1. Simply, it's going to be on this form. Limit x tends to infinity. The denominator will be x plus 1. For the denominator, remark, x squared minus x squared, they will cancel each other. then you will have positive 1 minus x. Start differentiating using L'Hopital or divide both the denominator or the denominator on the highest part of the denominator. You will have this value equal to -1. So now your inclined asymptote is the function y equal x minus 1. This is the inclined asymptote. I have vertical asymptote at -1 and I have inclined asymptote at x negative 1. Having your asymptotes, 95% of your problems you will be able to graph it or to sketch this function once you have these two results. A vertical at x equal -1 and an inclined asymptote y equal x minus 1. See, I will sketch it first, although we should get the maximum and the minimum, then start to sketch it. I can sketch it right now just only from the knowledge of the asymptotes. It's really very simple. See how I'm going to go do this. Already from the previous steps, we already have the knowledge that we have a vertical asymptote which exists at x equal -1, and we have an inclined asymptote at y which equal x minus 1. If you want to graph it straight away, few substitutions, knowing the asymptotes, you are done. This is y and this is x. I will start graphing the vertical asymptote, which starts at -1. So this is -1. This is my vertical asymptote. Then I will need to sketch y equal x minus 1. Already very simple. If you remark, you can get the y-intercept and the x-intercepts, then we can draw it. If we insert x equal to 0, it will devolve y at -1. And if you put y equal to 0, you will have x at +1. So simply, this is your inclined asymptote. It will be something like this. This is your inclined asymptote, y, which equal to x minus 1. Now, we can speculate the shape of this function. Simply, all you have to do is to find some value bigger than -1 and another value less than -1. Remark. The function is restricted. If the function exists here, it will have to go through these asymptotes. So it will go like this. This is the shape. If the function already exists in here, it will have to go near the asymptote. So this is the shape. So all I have to do is just to be sure where is your function at. Like how to do this? Simply by substituting. I will choose a value. Let's say 0. If I stood for 0 for the right side, and this is the right side, I will take 0. Let's first of all be sure about when x equal to 0, that inclined asymptote will be cut at -1. I will take 0 and I will start substituting in this function. 0 plus 1 is going to be 1. Divided by 0 plus 1 is going to be 1. 1 over 1, so your function is here. The function is between these two asymptotes. It is done. Your function must go like this. It will be near. It will be near to the vertical asymptote. Then it will have to go near to the inclined asymptote in this manner. So this is mainly your function. In the right part, in the right side. 99%. It will be reflected on the other side. Also, very, very simple. All I have to do is to find if the function exists here or there. How to do this? Just pick a number. Let's say this is -1. I will go for -2. -2, you have to be sure about two values. First of all, this value on the inclined asymptote. -2, -2, negative 1. So this value is at negative 3 on the y-axis. I will take negative 2 and I will start substituting in the main function, which is very, very important. Negative 2 to the power of 2 is going to be 4 plus 1, you will have 5, divided by negative 1. So this is negative 3 and this is negative 5. The function is under the other curve, so it has to go like this. This is the other shape of the function, or the remaining part of this function. This part is between the inclined and the vertical, and the other one is between the inclined and the vertical. We are done. We already did write it exactly. If it is required to find the domain and range, the domain is very, very simple. The domain, you can write the domain right now. The domain will be x belongs to R except at negative 1. But for the range, it will be R except. This area will be determined by using your maximum and the minimum, which you will have to get done. I hope the steps are already clear for you. See, I will go for the maximum and minimum. First of all, this is the function x plus 1, x squared plus 1. I will start differentiating, getting the denominator squared, which is going to be x plus 1 to the power of 2. Differentiate the denominator, which is going to be 2x times x plus 1, minus vice versa. Differentiating the denominator is going to be 1 times x squared plus 1. You will end up having x squared plus 2x minus 1. This value will be put to equal to 0. This is how to get critical point y dash equal to 0. Once we do f dash equal to 0, leave the denominator, whatever it takes. You are dealing with the denominator only. So all I have to do is to take x squared plus 2x minus 1 equal to 0. Don't look at the denominator, just look at the denominator, which when you try to analyze it, it will give you two values, 0.41, negative 2.41. These are the two critical values. Then I will start to get the f double dash. It's a good idea at this point. Once you have x1 0.41, x2 negative 2.41, start substituting x1 0.41 in this function. You will get the value of y. Then replace every x by negative 2.41. You will get the value of the second critical point. Then start differentiating. Then start substituting with the value of 0.41, negative 2.41. 0.41, it will develop a local minimum point. The negative 2.41, it will develop a maximum point. Based on these results, I already have all the points with me. This is the minimum, this is the maximum. The next step, I will start to draw the curve. Remember that 0.41 already exists on the positive side, and it makes sense. The minimum point, it's in its projected place. Same way like negative 2.41 on the other side. This is mainly what the first exam or the first classwork that we took previously. I believe a month and something ago. It was really a very nice exam. Let's go for classwork 2. Classwork 2 is dedicated, and I've already told you about this. Classwork 1, it will cover half of your ILOs. Classwork 2, it will cover the other 50%. Putting them together, you will have a very good shape, or you can speculate the shape of the final exam. Once more, start. This part is really very fun. It's about integration. Okay? The final exam will be 10 questions covering all the items. There are 10 questions, but they contain parts within these questions. And this, how it will cover, once more, I've stressed on this main point more than once, and please tell them all. The final exam is going to cover every little thing that we did go through, from the first till the Sometimes I wonder how someone could get these problems wrong with the knowledge of the main laws that we did go through. Please feel free, if you have a commitment to so, you can go. Okay? I'm recording everything for you, and then we'll upload it later, inshallah, today. Okay?
يعني order the group كله 10 questions from the beginning.
Till the end of almost. Almost five dedicated to the first part, and another 5 dedicated to the second part. Okay? Start integrating. I have 3x to the power of 2 plus 3 times e to the power of x cubed plus 3x minus 4. So start remembering the main rule for integration for this type or grade of functions. I want to integrate f dash x times e to the power of f of x dx, which is once the condition is given, simply the result will be e to the power of f of x plus a constant. This is the main form. It's really a very simple problem. It's exactly. I wonder how people could get this wrong. If you try to check this condition, you will find the derivative of the bar, the condition, which is simply 3x squared plus 3, really exists in front of your eyes. So all I have to do is to state that I equals e to the power of x cubed plus 3x minus 4 plus a constant, which is right. If I went to the other problem, which is problem number B, and remember that I have a law that states if you have f dash x divided by f of x dx, and you have the condition that the denominator in the derivation or the derivative of the denominator